can solve by factoring. You can solve with the quadratic formula. There's other methods, completing the square, graphing. But either way, we'll just be solving by factoring or by using the quadratic formula. So anyhow, I'll just start you out with telling you these first couple problems are already factored. These are already factored. So since they're already factored, I just need to do the very last step, which is solving. All I have to do is, and remember when you're talking about factors, when you say the word factor, you're talking about values that are being multiplied. So anytime values are being multiplied, you can call those values factors. So like up at the top here, if a times b equals 0, then a equals 0 or b equals 0. Now that may sound wordy at first, but think about it. It's saying is if you multiply two values and the product is 0, then one of those numbers has to be 0. There's no way you could multiply these two values and get 0 unless one of them is 0. So either a is 0 or b is 0. So same concept here. My factors, though, are a little more complicated, right? They're binomials. So I'm multiplying x minus 5 by x minus 2, and the answer is 0, meaning either x minus 5 has to be 0, or x minus 2 has to be 0. So you literally just write those equations and solve. So there you, again, one of these has to be 0 or both. So set each one equal to 0 and solve. Add 5, get x equals 5. Or on this one, add 2, and you get x equals 2. In the next one, your factors are x and x minus 2. Again, remember, things that you multiply are factors. So multiplying x times x minus 2, and the answer is 0, meaning either x equals 0 or x minus 2 equals 0. Solve it. X equals 2. This one is already solved. So x is either 0 or 2. Down here you have the same thing where your quadratic equations are already in factored form. So these we don't have to factor, and I'll advise you don't multiply here. If you multiply here, you're making more work, because really what you want is a factored answer. That way you can set each factor equal to 0 and solve. So subtract 6. X is negative 6, and here add 3, x is 3. So these are really that simple, meaning they're one step and done pretty much, or two steps, I guess, depending on how you think about it. Same thing here. This is already factored. You don't want to multiply that. You just want to set each factor equal to 0. Remember, if you multiply two values and the answer is 0, one of them has to be 0, if not both. So set both factors equal to 0. In this case, we do have a two-step equation. Subtract 5. 3x equals negative 5. Divide by 3. And x equals negative 5/3. Here we just have one step, add 2, and x equals 2. So again, if the equations are already factored, you don't want to multiply that out. You just want to set the factors equal to 0 and solve. If they're not factored, you can read the steps up here, but if they're not factored, you want to get all the, like in this one, you want to get all the terms over to the left side. That way it equals 0. You want to set it equal to 0. So subtract 35. You subtract 35, both sides is equal to 0. Now I have to factor it. Remember, factoring, remember a, b, c. When a is 1, factoring is fairly simple. You could make a list of factors. Remember, you need two numbers you can multiply to get negative 35 that add up to negative 2. So I don't always want to make a list of factors if I can just think of the numbers, but just a reminder of what I'm thinking, right? I'm thinking of numbers I can multiply to get negative 35, and I want the pair of numbers that adds up to negative 2, so 5 and negative 7. So my factored form is x plus 5 and x plus 7, still equals 0. Set each factor equal to 0 and solve. So subtract 5 to get x equals negative 5, and then add 7 to get x equals 7. Keep plugging along here. Same thing on this one. I want to subtract 16 over to set it equal to 0. Subtract 16 over, and then think of two numbers, right? Remember, if a equals 1, you might just be able to think of the two numbers that you need to factor this, right? Remember your factored form. Factoring is simply what we did in the last lesson, so don't let it be too complicated. 6.6 part 1, we did factoring. Now we're just throwing in the one extra step where it equals 0 and we solve it. But the factoring is really the harder part. So anyhow, on this one I need two numbers I can multiply to get negative 16 that add up to negative 6. You can make a list of numbers that you can multiply to get negative 16, but maybe you don't have to. Maybe you just know that negative 8 times 2 is negative 16, and negative 8 plus 2 is negative 6. Again, that's going to be negative 8 and positive 2. Those are my numbers that would work, again, to multiply to give me negative 16, but when I add, I get negative 6. So once I have that, still equals 0, set your factors equal to 0, just so you don't mess up. Solve, right, add 8, x equals 8, subtract 2, x equals negative 2. This next problem looks kind of like a pain, but it's doable. Remember, you definitely want to identify A, B, and C for this. Remember, if A is not 1, it's definitely a little more complicated. So if A is not 1, you definitely want to identify A, B, and C. And C is 40. And you don't have to write it down, but you still have to like mentally identify what A, B, and C are. That way all the steps kind of like can fall into place. So what I want to do is multiply A times C. But oh, by the way, look for a GCF. 5, negative 33, and 40 don't have any common factors. There's no GCF. So next step in my factoring, if you look back at 6.6 part 1, it would say multiply A times C. In this case, multiplying A times C is 5 times 40. That's 200. That's kind of a pain because there's a lot of factors of 200, but anyhow, I need factors, right, of 200, numbers I can multiply to get 200, but they need to add up to negative 33. So I don't know what that is, so I want to just make a list of numbers. By the way, they should both be negative. They should both be negative because when you multiply two negative numbers, you can get that positive 200, but they need to add up to a negative 33. So two negative numbers is the ticket here. Negative 2 times 100, 3 won't work, 4 works. Negative 4 times negative 50. I'm just going to keep going here. Also, don't forget a calculator, right? If you're not sure about your factors, you could simply use a calculator. 5 works. Negative 5 times negative 40. Looks like I'm getting kind of close here, but not quite. 6, I'm pretty sure 6 doesn't work, but we could double check. 200 divided by 6, no, that doesn't work. 7 doesn't work either. If I'm not sure, I can just double check. 8 works. Negative 8 times negative 25. Getting closer on my list here. By the way, if you do see the answer, you can stop. So like I know this is my answer here. Negative 8 plus negative 25 is going to give me that negative 33 I'm looking for. But let's just say you don't notice you have your answer. You can keep going with your list. 200 divided by 9. That doesn't work. 200 divided by 10 would work. So negative 10 times negative 20. 11 won't work. 12 won't work. 13 won't work. 14 won't work. 15 won't work. 16 won't work. 17, 18. None of those numbers will divide evenly into 200. So I think that's our whole list there, but again, you could double check on your calculator. And again, like I said, this one's the answer. The correct pair is the pair that adds up to negative 33. So the next step would be substitute. Substitute, rewrite the original equation, but substitute for the middle term, right? The two new terms, which are going to be negative 8x and negative 25x. So So I'm getting rid of the minus 33x, and I'm replacing it with the two factors I came up with. And remember, this is factoring by grouping, so same as the previous lesson, just with that one fairly basic step at the end, put a plus sign in between, factor out the common factor, right? So you group your terms, first two terms, second two terms, factor out the common factor from each group. So here, let's factor out the common factor x to end up with 5x minus 8. I do have a negative 25 here, so I want to factor out a negative number. In this case, 25 and 40, I can divide by negative 5. So factor out a negative 5. And this will, remember, factoring is dividing. So negative 25 divided by negative 5 is 5x. 40 divided by negative 5 is minus 8. Just like these problems in the previous notes where we're factoring a trinomial square, a does not equal 1. They end nicely for us, where the first group and the second group now have a common factor. It's a binomial. They both have 5x minus 8. So we're essentially now factoring that out from each group, and in doing so, we are left with x minus 5. So still equals 0. So finally, the hard part's done, the factoring, and I can now take my two factors, set each one equal to 0 as I was doing on the previous page, and solve. So on this one I'll add 8 and divide by 5. So one of my answers is 8/5. On the other one all I have to do is add 5. So my answers are 8/5 and 5 on this one. The next one, same thing. At least it's not 200 though, so there's less factors, but either way. A, B, and C, right? A, B, C, 2, 7, and negative 4. There's no GCF here. There's no common factors between 2, 7, and 4. However, I could keep going with the next step. Multiply A times C. 2 times negative 4 is negative 8. I need numbers that I can multiply to get negative 8 that add up to 7. The only way I can multiply to get a negative number is one positive number, one negative number. So I'm just going to make the whole list here, just so you know, like you could make the whole list. Certain numbers are not as logical, but right, if I need to add up to a positive 7, then the first two pairs are not really even logical to use, but either way, I need a positive 7, so this is my pair, negative 1 plus 8, 7. So I'm going to now replace my middle term, 7x, with negative 1x plus 8x, just following the steps that I had went over with you in the previous notes. Group, and from each group factor out the greatest common factor. In the first group I can factor out an x to get 2x minus 1. In the second group I can factor out a 4 to get 2x minus 1. Remember, factoring is like dividing, so 8 divided by 4 is 2, right? And 4 divided by 4 is 1. And anyhow, you now see if it doesn't jump out at you, again, let me just point it out that each group now has a common factor, 2x minus 1, so I can factor that out from each group. I can factor out 2x minus 1 from each group. Remember, crossing it out just kind of helps me see what's left here, x plus 4. So there's that, and then again, same thing. Now that I have my two factors, I can pretty easily set them equal to 0, each one, and solve. So I'm going to add 1, divide by 2, x is 1/2. On this one, I'm just adding 4 and I'm done, so x is 4. And then we have a couple little ideas here that I think you've seen before, but either way, I'll go over them. So we have the quadratic formula. If you ever had Mr. Omasuga or any other teachers, they probably sang you this song. X equals negative b plus or minus square root b squared minus 4ac all over 2a. That's good times, right? So anyhow, you also have this other, you can see this b squared minus 4ac. It's in the quadratic formula. In fact, it's the part that's under the radical. And if you remember anything about radicals, you might remember this. If there's a negative number in here, that does not exist, basically. You can't take the square root of a negative number, at least not in this class, you can't. Anyhow, we don't deal with that. We don't deal with the square